So far we've learned multiple area and circumference formulas. Today we're going to apply those formulas to answer the following questions. In problem number 1, we need to find the perimeter of this shape. In order to find the perimeter, I need to find the length of the line that bounds the figure. So if I start right here, to go around to bound this figure, I need to include this length, and this length, and this length, and this length. Notice that I am not including this length right here. I don't need this to bound my figure. So my perimeter is made up of a couple different pieces. It's made up of this piece and this piece. I can't just take the perimeter of this rectangle and the perimeter of this sector and add them together. I need to break it down into the pieces that make it up. So to do that, I'm going to use the formula for the measure of an arc. So if I look at this shape, the angle is going to be 180 degrees. So my formula is going to be 180 degrees out of 360 degrees times 2 times pi times my radius. Well, if this length is 32, my radius is going to be half of that, 16. Plus this length and this length and this length, which is 32 plus 32 plus 32. So I'm going to do this math. 180 out of 360 is 1/2 times 2 times pi times 16 plus 32 and 32 is 64 plus another 32 gives me 96. And to do this math, I'm going to put everything over 1. And I have a 2 in my numerator and my denominator. They can cancel. I'm left with 16 pi over 1, and I don't even need to put that, plus 96 units. I cannot combine these two. I can't add 16 and 96 because they are unlike terms. I have 16 pi's and 96. To find the area, again, I'm going to problem solve and figure out what I need to add together to make this shape. Well, if I look at the shaded area, I have a sector plus a rectangle. So in order to create this compound shape, I need to add together this area of the sector and this area of this rectangle. So I'm going to break it down into these two formulas. The area of a sector is going to be theta out of 360, 180 degrees out of 360, times pi times my radius squared, plus this area. Well, to figure out this area, I'm going to have to use the area of a parallelogram, base times height, 32 times 32. 180 out of 360 simplifies down to 1/2 times pi times 16 squared. I'm going to use my calculator. 256 plus 32 times 32. I'm going to have to use my calculator. 1024. One half times 256. Well, 256 and 2 are both even. 2 divided by 2 is 1. 256 divided by 2 is, well, if I take 250 and divide it by 2, I get 125. and then I take 3 and I divide by 2, I get, or excuse me, if I take 6 and divide by 2, I get 3. So I have 125 plus another 3, so I have 128. So my final answer for the area is 128 pi plus 1024 units squared. So to figure out this compound shape, I had to add together all the lines that bounded my figure. And in this case, I needed to add together my two shapes to create the entire figure. Let's look at problem number 2. In problem number 2, the perimeter is made up of two parts. The first part is this line right here. So the first part of my perimeter is that straight line. The second part of my perimeter is this arc length. Well, let's problem solve and figure these things out. To figure out this length, I'm going to look at this triangle right here. 12 is a radius of the circle, which means that this is also a radius of a circle. And all radii are similar, so this length is going to have to be 12 also. So if this side is 12 and this side is 12, this has to be an isosceles triangle. And if we have an isosceles triangle with an angle 60 degrees, all my angles have to be 60 degrees, which means all my sides are equal. I have an equal angular equilateral triangle. So the length of this line is 12. Now I need to figure out the length of this arc. Well, to figure out this arc length, I'm going to use this formula. The angle theta that creates this arc is 60 degrees out of 360 degrees times 2 times pi times 12. So I'm going to have 12 plus, I can cross out my zeros, 6 out of 36 is 1/6 times 2 times pi times 12. Put everything over 1. 2 and 6 reduce down to 1/3. 12 and 3 reduce down to 4 over 1. So my final answer is 12 and 4 pi units. The area in this problem is a little bit trickier. I want the area of just this shaded piece right here. To get that, I'm going to find the area of my entire sector and then subtract off the area of this triangle. So if I find the area of my entire sector, I'm going to have all of this area, and I subtract off just my triangle, I'm going to be left with just that little sliver of a shaded area. If I took this sector and I cut off this triangle right here, I'd be left with just this sliver. So this is how I want to figure out this area. There is no formula to figure out this gray area, so I'm going to have to make it by subtracting two other areas. So step 1, find the area of this sector. So I'm going to take theta out of 360 times, well, I'm going to use the area of a sector formula, pi times r squared, minus the area of this triangle. The area of a triangle is 1/2 times base times height. Well, I know the base of my triangle is going to be 12. What I need to figure out is how big my height is. To figure out my height, I'm going to draw in my height. And if I look at this triangle right here, I have a 30, 60, 90 triangle. Half of an equilateral triangle will be a 30, 60, 90 triangle, and this side right here is going to be half of 12, 6. So to go from this side to my height, I'm going to have to take this number times the square root of 3. Let's simplify. 60 out of 360 is 1/6 times pi times 12 squared is 144 minus 1/2 times 12 times 6 square roots of 3. (144) and 6 are both divisible by 2. 144 divided by 2 is going to be, well, if I take 140 and divide by 2, I get 70. And if I take 4 and divide by 2, I get 2. So it's going to be 72. Now 72 and 3 are both divisible by 3. 3 divided by 3 is 1. 72 divided by 3 is going to be 24. If I had 3/4, I'd have 75 cents. So if I have 1 less penny per quarter, I'm going to have 3 less cents compared to 75 cents. So this simplifies down to 24 pi minus 2 and 12 simplify down to 6 over 1. 6 times 6 square roots of 3 gives me 36 square roots of 3 units squared. So to figure out compound shapes, the perimeter is always the lengths of the lines that bound the figure added together. No matter what my shape is, I'm going to always add each line. Perimeter, I'm always adding lengths together because perimeter is going to always be getting longer. To figure out the area, sometimes I'm going to add. In this case, I add because I'm going to take a square and add on a semicircle. In this example, to figure out this area, I'm going to actually have to subtract. So to figure out if I add or subtract for the area, I'm going to have to problem solve. Here I subtract because I want to get rid of this triangle to be left with just this sliver.